Hello, welcome back to another video. So in this video we are still looking at the application or the use of the sum formula or the series formula for the geometric series. Here they explicitly asked us to calculate or to determine rather the sum to infinity, which is the one thing that the previous question was not asking us to do, but we ended up doing it nonetheless so that we can see how to use the formula. So we are just going to do this one where we are explicitly asked to do it so that you get to see how it can work, even though you've already seen it, but just hang in there and see how we do it. Solution. Okay, in this case we already know that this is a geometric series. If you didn't know that it's a geometric series, you can always just divide any two consecutive terms and see if you get a constant ratio. Then you will know that this is definitely a geometric series. So assuming that we already know, we don't need to do any divisions, we know. So okay, let's determine the value of n for which the sum of the first n terms is 1 to 1. So we'll use the sum to n formula, which is like this: r exponent 1 minus 1 over r minus 1. Okay, they told us that for which the sum of the first n terms, so that is basically the Sn, which is 121 over 27. What is our value of a? Our value of a is equal to the first term, which is 3. What is r? R is actually 1 over 3. You can just take term 2 divided by term 1. That is gives you 1 over 3. So because we are going to have different brackets here, so we'd rather use square brackets outside like this. Okay, so the n is what we are looking for, minus 1. So here you will see the thing that I'm trying to show you is how to solve this problem when you end up with some logarithmic or some mixed up simplification when you're trying to simplify. That's basically the reason why I found this interesting. Okay, 121 over 27. You keep simplifying like that. You get 1 over 3 exponent n minus 1. The denominator can be simplified to 1 over 3 minus 1. That is 2 over 3, like that. So is 1 over 3 minus 1 2 over 3, or am I lying to myself? Let's make sure. It is negative 2 over 3, not positive 2 over 3. So negative 2 over 3. That is actually what is happening there in the denominator. So now to simplify this thing, we can just say 3 divided by negative 2 over 3 and find out what that is. 3 divided by negative 2 over 3, that is negative 9 over 3. And then when you take that negative 9 over 3, we move it to the other side. But let's just write this thing in full before we try to complicate everyone's life. Negative 9 over 2, like that. That is 3 over, that is basically just 3 divided by negative 2 over 3. And then in this bracket you're still left with 1 over 3 all exponent n minus 1. And then you continue simplifying. Now what you can do is just to divide by negative 9 over 2 on both sides. Whatever you have there, divided by negative 9 over 2. This and that, they will cancel each other like that. So on the right hand side, or I mean on the left hand side, you will be having 121 over 27 all divided by negative 9 over 2. What do you get? You get negative 242 over 243. That's what you will be left with. And then on the right hand side you have 1 over 3 exponent n minus 1. You move 1 to the other side. What do you have? You have what you have on the left hand side, basically that plus 1. So when you have what you have on the right hand side and you add 1 to it, that gives you 1 over 2, 4, 3. That becomes your left hand side. 1 over 3 on the right hand side, exponent n. Now you are here, you are trying to simplify. Remember that 2, 4, 3, it can be written as 3 exponent 5 if I'm not mistaken. So you can always confirm that 2, 4, 3 equals to, and shift fact, that's exactly like that. So on this side you can write this as 3 exponent minus 1 exponent n, like that. And then what is happening, you can write this on the left hand side as 3 exponent negative 5, and then on the right hand side negative n, like that. That means negative 5 equals to negative n, therefore n equals to 5. So the main thing was just to deal with the simplification part of it. That's why I chose this question for us to do it. And then moving on to the second part, they're asking us to determine the sum to infinity. This one is very straightforward. Sum to infinity, there's only one formula, 1 minus r, like that, a over 1 minus r. So we know already our a is 3, 1, the ratio is 1 over 3. So now just need to punch on the calculator, and then we know what we get. That is 3 over 1 minus 1 over 3. That gives you 9 over 2. 9 over 2, that is the same as 4.5. Okay, you could write it like this, or just leave it as 9 over 2, sum to infinity, like that. Okay, let me just present another problem in this very same video, and then we can move to sigma notations. So this will basically be is it, because the previous question was D, this would be E. So suppose you are given a question like this, where they ask you to determine 5 minus okay, let me just write the right question. 5 minus 2.5 plus 1.25 minus 0.625, like that, plus that dot. So they are basically asking you to determine that. Just give us, basically just keep adding these numbers considering their signs, and then give us the value. So here, that's the question, there's nothing more to it. So what you can pick up from here is that this question or the series, it continues to infinity. Therefore the only way to determine this is to use the sum to infinity. But if you are going to be using the sum to infinity, you must be sure that this is actually a geometric series. To make sure, like I said it before, you just take a term, you divide by the odd. So one other thing that you could do for yourself is to just write this series as a sequence. Instead of the plus signs and the minus signs, just separate them with that semicolon, like that, so that you can deal with the sequence that we are used to. Minus 0.625, like that. Then you will see that this is your term 1, term 2, term 3, term 4. And then now now you know that T2 divided by T1, it's basically negative 2.5 divided by 5. What is the value that you get there? You can check with the other one, T3 divided by T2. You will see that you have 1.25 divided by negative 2.5. You have negative something. What is the value of that? Negative 2.5 divided by 5. That gives you negative 1 over 2. And then negative 1.25, not negative 1.25, divided by negative 2.5. What do you get? You get negative 1 over 2 again. This proves that you actually have a geometric series. So you are sure that this is a geometric series, and the r is actually equals to negative 1 over 2, and a is the first term, which is equals to 5. So you can use the sum to infinity formula, which is a over 1 minus r, and then you just need to substitute your a being 5, 1 minus 1 over 2, and then you give us your final answer. That should give you 10 over 3. Then you are done. So the only thing about this question was that they just say determine this series. They didn't tell you determine to infinity or anything like that, as they would usually do in the other questions that we have already done. So you just needed to look at the question and realize that basically, because they didn't say much, but this series, it goes all the way to infinity. For me to determine it in full, I must use the sum to infinity formula, and then you use that formula. Just before using it, need to prove that it is actually a geometric series. Then you can use the formula. You have proved that, you've used the formula, then you're done. Thank you for watching. We'll see each other in the next video.